All right, you guys, we're going to go ahead and start page 2 of your notes. And it shouldn't be too bad. We're going to start finishing off with something that kind of coincides with the last graph we did on the first page in the other video. And we're going to talk about rate of change. You guys probably remember rate of change from, well, honestly, you probably remember it from Algebra 1 a couple years ago. And the rate of change in Algebra 1 is slope. And most of you remember it, it's y2 minus y1 over x2 minus x1. There's another way to write that. All right, we're dealing with inputs and outputs. All right, so in order to talk about it in inputs and outputs, this x2 minus x1 stays the same, but we can write y2 as f of x2, and we can write y1 as f of x1, which really just means the output or the y value, as you can tell from this. So I'm going to let you choose. If we could write either one of those in right here. I will go ahead and I'll write this just like this. x2 minus x1, we'll count that as the division bar. I'm going to say f of x2 minus f of x1, and we'll say that's our formula. I'm using this, but it's really just a slope formula. All right. So your rate of change is the same as slope. It's how much your inputs change related to how much your outputs changed. And in this case, the outputs go on top, the y values go on top. Yeah, the outputs for the x's or the inputs for the x's go on bottom. So I'm going to look on here, and I'm going to see the original graph because they want us to talk about the rate of change from when x was 0 and when x was 2. And I've written the actual numbers for x is 0, input, output, but I want to show it to you. So if I come over here and I give my x value of 0, my y value is -1. And when my x value is 2, all right, my y value is 1. So these are the two values that we're dealing with. We have the rate of change between these. So let's go ahead and write that. All right, so given that interval, find my rate of change. So I'm going to go ahead and I'm going to write it using f of x. We'll say f of x, the second f of x, minus the first f of x. That's our y values that go on top. And x2 minus x1. Well, here we go. Well, f of x2 happens to be the output here, which is 1, minus, see, the first f of x, the first output, which is -1, literally, if you like slope better, y2 minus y1, right, over x2, which is 2, minus x1, which is 0. And if it makes it easier, you can label your x's x1, x2. You can label these f of x1 and f of x2 using subnotation. Well, we know that 1 minus -1 is the same as 1 plus 1, which gives me 2. 2 minus 0 is 2. So the rate of change is literally 1. That's the answer on this. My rate of change is 1. It's asking, and we can actually get this from just looking at the graph, right? If I went on here, and let me show you the graph. I went over from here. Every time I go over 1, I go up 1. Over 1, up 1. It looks a little bit different because they chose different scales. But it really is a rise of 1, a run of 1, a rise of 1, a run of 1. They said give two intervals and that have the same rate of change. I'm going to do that in interval notation, and we can see a few here. So let's use the one that we just did. So from 0 to 2, that interval, I'm going to say and I can kind of see these lines that run parallel. So I could say from 4 to 6. I'm going to say and. I'm going to say from 8 to 10. Check the graph to make sure you know what I'm talking about right there. All right. Now, we've come to a different learning target. All right. So I'm going to go ahead. I got my little marks here. I'm going to highlight the next learning target. We're going to go through this. Here's where you get to where a lot of people want to turn off, right? What you have there is you have a word problem. But I'm going to go through this. You're going to see it's not too difficult. All right, this learning target F says I can sketch a function's graph from a verbal description. So I'm going to take this verbal description and I'm going to sketch it. And let's scoot this up so you can see everything I'm dealing with right here. All right. And here we go. Let's just read this. It says the incidence of a disease is the rate which the disease occurs in the population. So we know we're talking about a disease in population. All right. It's calculated by dividing the number of new cases of the disease in a given period, typically a year. Wow, I bet you something down here has to do with years. And sure enough, look, my x-axis is years. By the size of the population. To avoid small decimal numbers, the rate is often expressed in terms of a large number of people rather than a single person. For instance, the incidence of measles. So here we go. The incidence of measles, and I'm going to underline this because I think this is probably important information, in the U.S. in 1974 was 10 cases per 100,000 people. All right. And instantly I look down here and I see this is everything over here represents 100,000 people. Right. This is incident cases per 100,000 people. So in 1974 there were 10 cases for 100,000 people. So I'm going to not even read because I see something. This is time in years since 1974. So I can go over here and say there were 10 cases per 100,000 people in 1974, and I already have a dot based on the information. I've already started on this graph. Now we'll read in, all right? From 1974 to 1980, there was a drastic fluctuation in the incidence of measles cases in the United States. In 1975, there was a slight increase. So I'm going to underline that. That means 1 year from 1974, there was a slight increase. And they don't tell us what that is. So I'm going to go over here, and I'm just going to go a tiny bit higher. I'm just modeling the information they tell me. The next 2 years saw a substantial increase in the incidence, which reached a maximum of 1977 at about 26 cases per 100,000 people. So it's really important that I understand this x-axis. Time and year since 1974, so I need to get to 1977. I'm going to count. 74, 75, 76, 77. I'm even going to put a little 77 here to mark it so I don't have to count again. And I'm going to go up to 26 cases. So 25, 26, and I've marked it. All right. From 1977 and 1979, so I'm going to come over here and write 79. The cases fell to about 5 cases per 100,000 years. Wow, a huge decline. So I came down here. All right. I'm going to underline that in case I want to check my work later. All right. The incidence fell much faster from 77 to 78 than 78 to 79. So it says from 77, and if you notice, I actually made a mistake. I put that dot in the wrong spot. So I'm going to erase this one and put that one in. So what that says is it says that first year that my drop was much more drastic than this one. It doesn't give me specifics, right? But I'm going to say, hey, maybe I dropped down to here. All right. All right. Finally, from 79 to 90, the incidence stayed about the same. So from 79 to 80, 1980, it's about the same. So I'm going to put a dot right there. All right. So we sketched a graph. These are distinct points they've given us, but I'm going to go ahead and kind of connect them so you can see an estimate, right, of how these points took place. We can see the slopes from any given point. All right. Let's go ahead and do this. All right. Sketch the graph of the function, which we just did. All right. The graph is horizontal, so from 1979 to 1980, let's check our work. It is definitely horizontal. What can you say about the rate of change of the function on that interval? Well, what kind of change happens right here? Did it go up? Did it go down? Did it stay the same? And it looks like it stayed the same, so there was no change. All right, it remained constant, which they already said. All right, so we will say there was no change. And that's just words saying, and I'm even going to write constant. So we finished this page already. If you'll notice on the next page, it says your turn. All right, so I'm going to highlight this your turn. This is something you will discuss in your group tomorrow, and I am going to be done with this video. Thank you.